beginning, God created the heavens and the earth. And God said, "Let the waters under the heaven be gathered together unto one place, and let the dry land appear." And God called the dry land earth, and the gathering together of the waters called he seas. Two realms fashioned by the hand of God, the earth, habitation of man, and the sea, commanded to bring forth abundantly the moving creature that hath life. The sea's family is an immense one, comprising creatures of every conceivable size, shape, and color. Literal fulfillment of God's creative command, "Be fruitful and multiply, and fill the waters of the seas." Yes, the sea is a strange and wonderful part of God's universe. But this is our world, a world of familiar sights and sounds. The ear tells us almost as much as the eye about the realm in which we live. Yes, sounds tell us a lot about our world. But beneath the sea, man is awed by an overwhelming silence. His ear tells him practically nothing here. Little wonder that long ago the sea became known as the silent deep, and that through the years writings on marine life should support that theory. Man stated positively that the sea was as silent as the proverbial tomb, such as this quotation from a prominent European aquarium guide. "If some of the crustaceans and fish can make noises, they are so rare and can be heard at such short distances that one can almost neglect them. Beneath the water, ardor, hunger, and agony of death are silent, and even were they not so, there would be no ear to hear them." With the advent of the 20th century, a wonderful new age was ushered in. The age of radio, with the development of the vacuum tube to amplify feeble currents, and the microphone, changing sound waves into electrical energy. It was inevitable that before long someone would devise a method of using these early electronic instruments to listen beneath the sea. Though crude and hastily improvised, here was an instrument which could detect sounds from passing vessels, sounds beneath the sea. So the deep wasn't so silent after all. Yet that wasn't too startling a discovery. We already knew that sound travels 5 times faster through water than through air. Then if water is such a good conductor, why don't we hear sounds from the sea? Well, one reason is that the air-water boundary is almost as effective as a solid wall. But even more important, the human ear simply doesn't work well in water. For this realm, new ears are needed, ears expressly designed for operation below. It was this realization which led to the development of an instrument known as the hydrophone, an underwater microphone which detected sounds in the sea with a clarity never dreamed possible. In 1941, man's new knowledge of the sea became a matter of survival. This was sonar. Sound pulses echoing back to hydrophones gave direction and range with amazing accuracy. But it was a battery of hydrophones installed across the entrance to Chesapeake Bay as a part of the nation's defense system that led to a fascinating discovery. The hydrophones terminated on a control panel where flashing lights enabled operators to plot the positions of moving ships. It was a late spring evening in 1942 when tests were completed and the night operators settled down for their first lonely vigil. Suddenly, red lights flared on the panel, warning signals from those hydrophones in the bay. What caused these strange sounds? No evidence of any unusual craft could be found. Yet each evening the phenomenon occurred and soon became one of the most baffling mysteries of the war. The military turned to the scientists for help. And at last the answer came with the clatter of the teletype. Disregard unusual hydrophone signals. Sounds made by schools of fish known as croakers. Fish that talk. When the war ended, the story of sounds beneath the sea could at last be told. And from laboratories in Los Angeles, a team from the Moody Institute of Science embarked on a historic mission, the filming of the first underwater sound motion picture. Thus began a series of descents into that blue realm of water. Here was a world whose shapes and colors had been familiar for centuries, but a world in which man had been almost totally deaf. Deaf, that is, until new ears opened to him a realm as noisy and vibrant as his own. Some of the sounds were rather easily traceable. Others remained unidentified, particularly those that welled up mysteriously from the darkness of the night sea. Not all sound makers are as easily identified as our friend here. And so relentless research has continued over the years. At places like the Narragansett Marine Laboratory, where Dr. Marie Polenfish and her staff have painstakingly analyzed and cataloged the sounds of hundreds of species of fish, crustaceans, mollusks, and mammals. So characteristic is the sound each animal makes that sound spectrographs such as these become, in effect, voice prints, which clearly identify each sonic species. The inhabitants of the sea produce sound for much the same reasons as do terrestrial creatures. Some sounds are songs, repeated phrases, quite analogous, really, to birdsong, although in this case our singer happens to be a distant whale. Others suggest the droning of insects on a summer night. But most biological sounds are purposeful calls, warnings, or responses to fright or pain. The toadfish, for example, uses a loud drumming to declare territorial rights around his selected nesting site. It is his way of saying no trespassing. For his sweet young thing, however, he has a different tone of voice. Voice? Wait a minute. Fish do not have lungs, larynx, or vocal cords. Not even an air medium in which they would work. So how does a fish talk, anyway? Well, God has provided some pretty special equipment, more varied than the instruments of a symphony orchestra, and all designed to work in water. In many fishes, the sound-producing organ is an air-filled structure that is wrapped or banded with long muscle fibers. These thump or vibrate the resonating chambers, producing a variety of barks, grunts, or groans, depending on the species. We've heard from the croaker and toadfish. This is a common sea robin. Furfish possess a kind of built-in percussion section. A rasp-like device located in the throat is coupled to resonators which help amplify the sound. The skeleton is instrumental in producing the note of the longhorn sculpin. Bones of the pelvic girdle transmit muscular vibrations to the sides of the fish, which radiate sound like drumheads. These voices of the deep are new voices to most of us. This one, do you know what it is? Well, a spiny lobster. So far as we know, the lobster is the only animal that produces sound with the antennae. Without electronic ears, you might swim through a rocky seascape like this and never know it was inhabited by millions upon millions of tiny, snapping shrimp, some of the sea's most prolific noisemakers. But the hydrophone detects a crescendo of sound from these unseen little fellows. The snapping shrimp is a tiny crustacean, much smaller than his seafood cousin, averaging less than an inch in length. One of the shrimp's claws is larger than the other and is the noise-producing organ. In a normal population of these creatures, the individual clicks merge into a continuous crackling din. Of all sea creatures, perhaps none has proven more fascinating to man than the friendly dolphin or porpoise. Some have become stars of stage, screen, and television, delighting audiences with their antics, acrobatics, and their seeming pleasure in social contact with man. Dolphins are not fish, but warm-blooded, air-breathing mammals, possibly ranking second only to man in intelligence. The cheerful chirps and whistles that contribute to the fun of a sea circus can be emitted both above and below the surface of the water. And in the open sea, they're used to a certain extent for communication between members of a school. No ear to hear them? Nothing is further from the truth. The dolphin's entire body can receive sound. But the ears are especially designed for use in water, even at the crushing pressures of a 1,000-foot dive. The entire auditory system gives the animal an amazing sense of hearing, directionally accurate and sensitive to frequencies of over 180,000 hertz or cycles. That's far above the range of the human ear. But there's more. Rubber suction cups are placed over the eyes of this dolphin at Marineland of the Pacific in California. 3 rings are then tossed into the water. Although the animal is effectively blindfolded, he still unerringly locates and retrieves the rings, scoring bullseyes on all 3, by the way. How does he do it? With sonar, literally. Even when compared with the latest of man's sonar equipment, the dolphin's echo-ranging system seems incredibly sophisticated. In the vicinity of the blowhole are structures which produce intense pulses of complex sound. We hear these as rapid series of sharp clicks. The skull and other structures of the head direct most of the sound energy forward. Lower frequencies disperse in a wide pattern used for general locale soundings. The extreme high frequencies, however, concentrate into a narrow pencil beam which is used for scanning specific targets. The system which detects the returning echo is also highly directional. Oil-filled channels in the lower jaw apparently guide the signals directly to the middle ear. These echoes convey precise information concerning the size, shape, and range of objects, even something of their texture and composition. Just how good is the dolphin's sonar? Man is just beginning to find out. At the United States Navy's Marine Biology Facility at Point Mugu, California, a bottlenose dolphin named Doris can, while blindfolded, distinguish between the various materials used to make these target discs. In this particular experiment, her task will be to differentiate between 2 metals, copper and aluminum. A remarkable discrimination if she can do it. First, Doris is blindfolded and then sent to one end of the tank. The targets are set in place at the other end. The signal is given and Doris begins her run. In what for her is now total darkness, she must swim through the wickets, then identify the copper target, which is on your left. Listen. The whistle signals success and a reward. Before each run, the targets are raised and replaced in a completely random sequence. A switch this time, copper on the right. This will be a repeat. Copper is again on the right. Notice the scanning motion as she compares echoes from both targets before making her choice. A videotape recorder allows the action to be replayed, even slowed, so that the motions and sounds associated with echo ranging may be studied in detail. In experiments such as these, scientists continue to probe the full extent of the dolphin's sonic way of life. A way of life which depends upon the ability to locate food and avoid obstacles, even in water so murky that vision is well nigh impossible. A matter not just of convenience, but of survival. One would expect the largest creatures ever to have lived on Earth to be capable of some pretty thunderous noises. And indeed, some of the lowest frequencies known in the sea rumble forth from incredible giants like the humpback whale. pilot whales, however, for all their 2 or 3 tons, turn out to be the canaries of the sea. Size seems to be of little help in predicting the menagerie of voices belonging to whales. Some of the most astonishing undersea sounds ever recorded are these distress calls emitted by Namu, one of the first killer whales ever captured. As the animal was being towed towards Seattle and Puget Sound, other whales were sighted in the area. And on the hydrophone, the cries of Namu were heard, echoing through the channel waters. The vast domain of the great whales covers nearly 70% of our planet. To the north, the far north, the oceans dip beneath first scattered floes, then great masses of polar ice. Along these shifting, fragmented boundaries live some of the sea's most incredible musicians. This is the song of Erygnethus, the bearded seal. Bells, steel drums, something man-made. Well, the Eskimo knows what to look for. Walrus. Inflatable throat pouches of the adult male in the springtime account for the bell sound. In addition, both sexes emit rasps and clicks thought to be similar in function to the sonar pulses of the dolphin. Like the walrus, seals of the Arctic and Antarctic apparently possess effective sonic guidance systems. The Weddell seal, for example, thrives in the blackness beneath dense ice shelves, locates food 1,000 feet below any possible light penetration, and then homes in on a tiny, vital breathing hole somewhere in that frozen canopy 1/4 of a mile overhead. All this even through the blackness of the long polar night. It is here in these environs that we come to the startling realization that this so-called silent deep actually abounds with creatures whose very existence depends upon sound. Here, the blind may live. It is the deaf that die. Years ago, man put his head under the water, listened, couldn't hear anything, and so decided that there was no sound under the sea. To him, it was the silent deep. In other words, he made a test, discovered a fact, and reached a conclusion. The test was a simple one. He put his head under water and listened. The fact he discovered was obvious. He couldn't hear anything. The conclusion he reached seemed logical. After all, he had 2 good ears. If he couldn't hear anything, there just wasn't anything to hear. We now know that man reached the wrong conclusion. There was plenty of sound under the sea. Is it possible that man may have reached the wrong conclusion in some other areas as well? Not long ago, for many people, the automobile was the symbol of the good life. 2 cars in every garage was the slogan. The big, high-powered car was the mark of distinction for the successful man. Today, as we look back through the smog with burning eyes, we realize that man may have reached the wrong conclusion in many areas of his life, some of even greater importance than our physical environment. New moralities, for example, sweep a nation or a world with a strange idea that there are no absolute values, that concepts such as right and wrong are no longer important, that love of God, love of country, respect for family have somehow become irrelevant. What if these also are wrong conclusions? What terrible price will we have to pay if we're making a mistake in these vital areas? Listen to the sounds in the sea. And then remember that it is possible, even in this age of scientific achievement, to reach the wrong conclusion in matters of life and death importance for us and for all mankind.